because they want it for one calendar year. School calendar year starts in June. So we have to wait. But that should be off in the next day or so. Now, before we get started, I'm going to look at problem 22 from, what was it? 7.51. So last night's assignment. 3 over x minus 3. So that should be a 3. 22. X minus 3 is equal to, plus 1 over x is equal to x minus 1 over x minus 3. So that should be a plus. Yes. So we want to look at this one here first before we get started. Now, the first thing we can list off are the restrictions so that we have them. I don't believe that this one here, the restrictions are going to make a big difference, but it's good to have them listed anyways. So x minus 3's restriction would be 3, because 3 minus 3 would give us 0. Now, the x by itself, we would need it to be 0. And that takes care of all the restrictions. Now, the first thing we can do in solving for this is multiply every one of these terms by the same thing, so the denominators would cancel. So we would need x and x minus 3. X and x minus 3. Now, in the first one here, the x minus 3 and x minus 3 would cancel. In the middle, the x and x would cancel. In the last one, we have the x minus 3 and x minus 3. Okay, that's where I got. I knew I had a 2 somewhere. 2 right there. Thank you. Now, if we multiply together what we have left, in the first one here, we would have 2x plus x minus 3 is equal to, here we have x minus 1 times our x. Now we can combine like terms and distribute, because the one side x times x minus 1 will still need to distribute. But on the left-hand side, our 2x plus x is 3x. Minus 3 is equal to, here x times x is squared minus x. And we distribute the x here. Now at this point here, we do need to get everything on the same side and this thing equal to 0. Because we have a variable to a degree higher than 1, we have the x squared, we need it equal to 0. So the order in which we do this really doesn't matter, because we can subtract 3 first, 3x from both sides first, and then add 3. If you wanted to do it all in one step and write it out kind of like this here, I mean, that's fine also. But we'll do it in 2 steps, because if we subtract 3x from both sides, these cancel, telling me negative 3 is equal to x squared minus 4x. And lastly, we will add 3 to both sides to get this equal to 0, telling us that 0 is equal to x squared minus 4x plus 3. Now at this point here, we can factor our quadratic, the x squared minus 4x plus 3. Since the 3 is positive, the signs are the same and they match the sign of the middle term, which would be negative and negative. Now the factors of x squared are x and x, and the factors of 3 are 3 and 1 or 1 and 3. Now since they're both subtraction and just x and x, it really doesn't matter where we put them, because it works out to be the same thing. And it also works out that these here are actually the factors, x minus 1 and x minus 3. Now because we do have 2 things multiplied together to equal 0, one of these has to be 0. So what we can do is set both of them equal to 0. So x minus 1 is equal to 0, and x minus 3 is equal to 0. Now we just need to solve. So here we would add 1 to both sides, telling us x is equal to 1 is one of our solutions. And for the other, we would add 3 to both sides, telling us x is equal to 3. And those would be our two answers. Well, they did come back into play because we did say that x cannot be what? 3 or 0, yes? Well, we got one of the values is x equals 3, yes? So what do we say? So x is 1. And that's it. And that's what we're going to be delving into today, is with these restrictions. Now, the ones we had yesterday, none of those had a value, a solution for x that came up as one of the restrictions. This one's the first one that we see that has. Now, did the way that we went about solving this problem here change in any way, shape, or form from step 1 all the way to the end? Well, no. The only thing that changed when I got to the end was to say, well, since this solution here was one of the restrictions, we canceled it out and said, no, this is not one of the correct solutions, but the other one is, since it's not one of the restrictions. And that's the only real difference. Then we would have, and that's it. Now, because we went and did this first, we listed the restrictions first, we don't have to go back and plug them both back in to make sure that they do work, because we already have what the restrictions are. So one will be one that works. Because if we came back to the top and plugged one in, we would see that both sides would be the same. And it actually works out that both sides would be 0. Any other questions on the homework? All right. Let's look at these here today, the ones we're going to look at today. So this here is the first one we're going to look at. We have 3x over x plus 1 minus 5 over 2x is equal to 3 over 2x. So, as we just saw, it might be helpful to list the restrictions first. That way, if one of those values comes up, we don't have to plug it back in later, or plug both of them back in later to make sure that they do. So what would one of the restrictions be? -1, because that would be for our x plus 1. -1 would make that 0. And 0, because for our 2x, in both of the places that we have it, 0 would make the denominator 0. So those would be our two restrictions. And that would be it. Now that we have all the restrictions, we can go on and solve. From the 2x, because 2 times x equals, because we could divide both sides by 2, 0. Because whenever we have like 2x or just the variable by itself, there's no addition or subtraction. Even if it had been x squared, it'd still be 0. And if you're not sure about it, you can always set them equal to 0 and solve, and it'll tell us what value of x would make it 0. Any other questions? Now we need to multiply each of these terms by something so that the denominators simplify out. So what would we use to multiply? We would use the 2x for sure and the x plus 1. I like writing next to it because if we don't have to rewrite the whole problem again, I'd prefer not to. Now let's see what simplifies. On the first one, we have the x plus 1 and x plus 1. In the middle, we have the 2x and 2x, and in the last one we have 2x and 2x. So what are we left in the first? 3x times 6x squared minus 5 times is equal to 3 times x plus 1. Well, now we need to distribute and combine like terms where necessary. So the first thing we can do is distribute the negative 5. So negative 5 times x is negative 5x. Negative 5 times positive 1 would be negative 5 is equal to 3 times x would be 3x, and 3 times positive 1 would be positive 3. Now we need to get this equation equal to 0 because we do have an x squared. So the first thing we can do is subtract 3x from both sides. And if we subtract 3x from both sides, we get that 6x squared minus 8x minus 5 is equal to 3, because these would cancel out. And then the next thing we would need to do is subtract 3 from both sides, telling us that 6x squared minus 8x minus 8 is equal to 0. Okay, now at this point here we can solve it by the quadratic formula or we can factor it. Which one do y'all want to do? Factoring? Now if we factor it, the first thing we need to look for is a greatest common factor, 2. So we can factor 2 out of all 3 terms, leaving us with 3x squared minus 4x minus 4 is equal to 0. After we finish factoring that out, we can have 2, and then our 2 sets of parentheses with 3 spaces. Since the 4 is negative, the third term is negative, our signs are going to be opposite. One is going to be positive, one is going to be negative. Now the factors of 3x squared, well, we'll have x and x. So where do we want to put the 3? In the first set or the second set? I'll just put it here in the first set. Because again, we can check it here in a minute. Now the factors of 4 are 1 and 4 or 2 and 2. Let's try 2 and 2. Now off to the side, if you're not sure, we can always check it. I wouldn't check it underneath. We can do 3x times negative 2 would be negative 6x. 2 times x is going to be plus 2x. Negative 6x plus 2x is negative 4x. Is that what we wanted? Yes. So these here are the correct factors for this here. At this point here, we do have 2 things multiplied together to equal 0, yes? Actually, we have 3, because we have the 2, the 3x plus 2, and the x minus 2. But we're just focused on the 3x plus 2 is equal to 0, and the x minus 2 is equal to 0. Because the 2 out front, is there any way I can actually change its value? Well, no, there's no variable connected with it, so we're not actually concerned with the 2. We just are concerned with these 2 here. Well, the 3x plus 2 equals 0, well, the first thing we can do is subtract 2 from both sides, which will tell us that 3x is equal to negative 2. And last but not least, we would divide by 3, telling us x is equal to negative 2/3. And for the other one, we would add 2 to both sides, telling us x is equal to 2. Now, is either one of those our restrictions? Well, no, we said the restrictions were negative 1 and 2 and negative 2/3. Neither one of those are our restrictions, so those are our two solutions for this here. Any questions on this here? We good with this here? All right. Let's look at the next one. Now, before we start this and start working through this, or even finding the restrictions, we do need to factor the x squared minus 1. Because if there's any spot or any one of these that will factor, we need to factor them down. Because we don't want to add any extra factors in our multiplication across each term. Because each term or each set of factors that we add additionally will increase the degree of what we're working with. So with the last one, we ended up with a quadratic of degree 2. If we'd added another factor of x plus 1, it would have taken it from a degree 2 to a degree 3. It would increase it by 1 for each set of extra factors that we add. So we need to make sure we don't add any more than we absolutely need. So the first thing we need to factor is the x squared minus 1. Well, x squared minus 1 is a difference of perfect squares in factors to what? X plus 1 and x minus 1. So if we'd have left it as x squared minus 1, we would have actually added an extra factor of x plus 1 in each term. And it also helps us find out what the restrictions are. Because for the x plus 1 in the two spots, we cannot have x be negative 1. And for our x minus 1, we can't have x be 1. So if x is negative 1 or 1, it is an extraneous solution. It will not work for this problem. Now, what can we multiply each term by? X plus 1 and x minus 1. Plus 1 and x minus 1. So we're going to be multiplying each of these terms by x plus 1 and x minus 1. Now let's see what simplifies out. In the first one, we would have the x plus 1 and x plus 1. In the middle, well, we'd have the x plus 1 and x plus 1, x minus 1 and x minus 1. And well, with the 3, nothing simplifies. So what we're left with is in the first one, we would have 4x plus 1 times x minus 1 is equal to 12. Because everything's simplified out of the denominator. Plus 3 times, well, what do we have? X plus 1 and x minus 1, yes? Where did I get the x plus 1 and x minus 1? What? The denominator in the middle, yes, the x squared minus 1. So what is x plus 1 times x minus 1? X squared minus 1. Because if we factored it down to get it, and we already have it multiplied in the original problem, might as well just replace it. Now, if that's not something you notice as working them, especially on the homework, I mean, if we multiplied x plus 1 and x minus 1 out, we would get back to x squared minus 1. We would get back to it anyways. Any questions on this here? Okay. Now, we do need to distribute and solve. So here we're going to multiply through by the 4x. Well, 4x times x would be 4x squared. 4x times negative 1 would be negative 4x. 1 times x is going to be plus x. And 1 times negative 1 would be negative 1. Here we're going to distribute the 3. So 3 times x squared is going to be 3x squared. 3 times negative 1 would be negative 3. The 12 and negative 3? Or these two here? Well, this 3 is being multiplied with the x squared minus 1, so they're stuck together with that multiplication. So we'd have to solve the parentheses first before we can do the addition and subtraction. Yeah, no, good question. Now, since we've gotten rid of all the parentheses, we can do the addition and subtraction of like terms. And on the left side, we would have 4x squared. Negative 4x plus x would be negative 3x minus 1 is equal to, here we're going to have 3x squared. 12 minus 3 is going to be plus 9. Now at this point here, we do need to get everything on the same side of the equation because we have quadratics. We do have an x squared term. And what's the first thing we can do? Yeah, subtract the 3x squared. And if we subtract 3x squared from both sides, well, 4x squared minus 3x squared would be x squared. We'd have our minus 3x minus 1 is equal to 9. Now we can subtract 9 from both sides, which would tell us that we have x squared minus 3x minus 10 is equal to 0. Any questions on how we got down to this quadratic? There are some problems that we might occur eventually. I don't think so much in this chapter, where our quadratic terms might actually cancel out on both sides, which would be nice. But here, unfortunately, they did not. Now we can solve this by factoring. Yep. Still don't quite know how that's doing that. There is something a little funky. Okay, that's getting annoying. Yep. There we go. It'd have been hilarious if I get the first one and then does it on the next one. Now, because the 10 is negative, the signs are going to be opposite. One is going to be positive, one is going to be negative. Now, the factors of x squared are x and x. And the factors of 5 that we want would be 2 and 5. Which one do we want to be positive? 2, and the 5 would be negative. I have a feeling at this point, y'all have either already worked it all the way out and found x, or can see what the values of x are at this point here. But we would need to set these equal to 0 because any two things multiplied together to equal 0 means one of them has to be 0. So you'd have x plus 2 is equal to 0 and x minus 5 is equal to 0. So at this point here, we can subtract 2 from both sides, which tells me x is equal to negative 2. Here we would minus x is equal to 5. And we get these two answers here. Now again, we said that x cannot be what? Negative 1 and 1. Well, that's neither one of our answers, so both negative 2 and 5 are the solutions for this here. Any questions on any of this here? All right. We have two more that we're going to do today. We'll do this one and the next one. Now looking at this here, I know I'm going to need to rewrite this back out. For one main reason, because the middle denominator is what? X squared minus 9, yes? Will that factor? Yeah, it's a difference of perfect squares. So if one of the denominators is going to factor, well, we need to factor it. And since it is a difference of perfect squares, it actually factors out to x minus 3 and x plus 3. Or x plus 3 times x minus 3. Either order is fine. Now there's a good chance, well, I say good chance, I think there's a 100% chance that one of the restrictions will show up. How do we know that? It kind of told us. Because this one is extraneous solution, so most likely it's going to show up. Unfortunately, they won't tell us that on the homework or the test. Actually, I might have a kind of big bold check your answers. Might be a hint. So we do need to see what x cannot be. And looking at this here, well, we have the x minus 3 and x minus 3, so x cannot be 3. And then the other spots we have is x plus 3 and x plus 3, so x cannot be negative 3. So if we get a value of 3 or negative 3 for this problem, that solution does not work. Okay. Now that we've found all the extraneous solutions and have all the denominators factor, we can go on and start this problem. Now what do we need to multiply each term by? Yes, x minus 3 and x plus 3. And luckily, we only need the x minus 3 and x plus 3 once, because in each denominator, each one only shows up how many times? Once or not at all, because the first one doesn't have an x plus 3, and the last one doesn't have an x minus 3. But in any of them, each one of them only shows up once. Now when we simplify this, well, here the x minus 3 and x minus 3 would cancel. The middle, x minus 3 and x plus 3 would cancel. And in the last one, the x plus 3 and x plus 3 would cancel out, leaving us with 6 times S3 is equal to minus times x minus 3. Now at this point here, we need to simplify the parentheses. We need to do multiplication first. So here, we're going to distribute the 6, and then we would distribute the negative 4x. Well, 6 times x is 6, plus 6 times 3 is 18, is equal to, well, 8x squared is not going to change, but negative 4x times x is negative 4x squared. And negative 4x times negative 3 will be plus 12x. Now at this point here, we can combine like terms. Well, 6x plus 18 is equal to 8x squared minus 4x squared is 4x squared plus 12x. Now that we've combined all of our like terms, we need to get it equal to 0 because we do have an x squared. So we need to subtract 6x on both sides. Which should tell us that 18 is equal to 4x squared plus 6x. And last but not least, we need to subtract the 18, yes. Knew what you were going to say. 0 is equal to 4x squared plus 6x minus our 18. I have a feeling y'all want to factor more than use the quadratic formula. So when we factor this here, we do need to factor out any greatest common factors if there are any. And here there are. Because 2 will go into 4, 6, and 18. They're all divisible by 2. And if we factor 2 out of 4x squared, we're left with 2x squared. If we factor 2 out of 6x, we're left with 3x minus 9. And factoring out these greatest common factors, especially with our constant terms, these numbers, will make these a little bit easier to work with and a little bit simpler. So here we'll have 0. Okay. 0 is equal to 2 sets of parentheses. It's going to do it again, I know it. Since the third term is negative, we know our signs are going to be opposite. One is going to be positive, the other is going to be negative. Now the factors of 2x squared, well, for the x squared, we know we'll have x and x. For the 2, well, we'll have 2 and. So where do we want to put the 2? Front of the minus. And then the factors of 9 are 1 and 9 or 3 and. Which one do we want? 3 and 3. Now again, we can check this just to make sure we do have it correct. X times negative 3 would be negative 3x. 3 times positive 2x would be plus 6x, which would give us a positive 3x. We did want positive 3x, so we do have this factored correctly. Any questions on this here before we start the next step? Well, we have it factored and we have 2 or more things multiplied together to equal 0, so one of these, either x plus 3 is equal to 0 or 2x minus 3 is 0. And we can solve from here. So for the first one, we can subtract 3 from both sides, telling us x is equal to negative 3. So that's one of our solutions. For the other one, well, the first thing we can do is add 3 to both sides, telling us that 2x is equal to 3. And then divide by 2, telling us that x is equal to 3 over 2, 3 halves. Now what were our restrictions? 3 and negative 3, yes? Do we have one of those as an answer? Yes, the x minus 3. So that's not one of the solutions. And the only solution we actually have for this here is 3 halves. Okay. So we have this here. Are there any questions on any of this here? So looking at where we're at, I could probably get through this in the next 5 minutes, but I would be dragging y'all along the way. I think for the most part, most of y'all will be able to keep up, but I don't want to go at that speed just so we get one more problem done. Okay? So what we'll be doing tomorrow is we'll be finishing up these note sheets. So I'll be finishing this up, and you will be getting the last assignment there. Now, I do know that we do have inclement weather advisory going on. They haven't told us exactly what we'll be doing the rest of the week. If we do go virtual for the rest of the week, or tomorrow and the rest of Thursday and Friday, I will be posting tomorrow a video of the rest of these notes. Okay? So there will be a video posted up there. You will get the assignment attached to it. And there will be a quiz for attendance. The quiz for attendance is going to come straight from this here. So you'll answer like one or two questions. I'll pick one. Question one is like, what are the restrictions? You'll select the correct answer, and then what's the solution? Get both of those right, and you should by just watching the video. And you'll get it counted attendance there. If we do go virtual for the rest of the week, Thursday and Friday most likely will be makeup days. I'll throw up a question on there, some quiz for attendance, which should be pretty straightforward, either answering something from one of the videos or something like that there, where you can easily answer it, get it correct, get marked for your attendance. If you get it wrong, I'm going to mark you absent. And you need to get them turned in by the end of the day. So tomorrow, if we go virtual, you'll need it by the end of the day, because on Thursday, if you didn't answer it or got it wrong, I'm going to mark you absent. All right? Then, if that does happen, Monday when we come back will be the review. We'll go over it Tuesday. Test would be Wednesday. Okay? Awesome.